So far, we have seen how we can sniff networks and how we can de-authenticate clients from networks. Now we are going to start working on networks which are encrypted. So the first encrypted protocol in our list is WEP, which is known as Wired Equivalent Privacy. So first of all, we will look into the protocol and we will try to understand the protocol. Then we will start hacking into this protocol. So let's just start working on it. So first, WIP was the first wireless encryption protocol. It uses RC4 algorithm, which is a symmetric key encryption algorithm. So we will see how this algorithm works. So this algorithm contains a password, which is a web key. So a password could be 40 or 104 bit length. We combine this web key with initialization vector, and initialization vector could be any random 24 bit key. So by combining these two, we get either 64 bit key value or 128-bit key value. So this is a password. We put this password in access point when we set web. So this password could be 40-bit or 104-bit value. And initialization vector is a random key which is generated by this protocol. So by combining these two, we get 64-bit or 128-bit key, right? And then we pass this 128-bit or 64-bit key to the RC4 algorithm. This algorithm generates random key stream. This random key stream could be a very long random key value, and we will keep this thing into our pocket right now and see how we can use it. So this is how we generate a random key stream. The second part of the web algorithm is to check the integrity of the data, because data is passed in packets, and packets can be tampered and packet can lose some bits. So to maintain the integrity of data, we use CRC 32-bit algorithm, which uses few bits of data and generates a 32-bit ICV value, which remains same if we put the same data into it. So if we put same data again and again into it, we will get the same ICV value, right? And then we will combine this data with ICV value, right? In third step, we will generate ciphertext using random key, which we generated using WEP, and IV, which is a initialization vector, and we pass that into RC4 algorithm and we get this random key stream, right? We will perform a XOR operation on this random key stream and the data with ICV, so that we will get a ciphertext. We pass ciphertext along with the initialization vector. Now, ciphertext is in encrypted form, but this IV value, which is the initialization vector, is in the plain text, right? So we pass this to uh, client or supplicant, we can say. So how the supplicant decrypt this, right? Now we'll see how the supplicant decrypts this value. So IV is in plain text, as I told you. So supplicant can easily generate key stream using this IV, because supplicant also has this web key into it. So using the same algorithm and using the same IV, it can generate the random key stream again, and it will be the same key stream because of the IV, right? So then using this key stream, we will again perform XOR operation so that we will get the plain text, right? So this is how WIP works. So let me revise it again. So we have WEP key, which is a password. We combine it with initialization vector, which is a random 24-bit key. We pass it to a RC4 algorithm, which generates a random key string. Then in the next step, we have data, which is in plain text. We perform CRC operation on it to maintain the integrity of data. We combine ICV 32-bit with data, which is the integrity of the data, and we perform XOR operation with random key stream on it, so that we get a ciphertext. Then we pass this ciphertext along with the IV, which is the initialization vector, to client or supplicant. So the supplicant can decrypt this ciphertext in the same manner. So this is how WEP algorithm works. It is little complicated, so you can go this video again one more time if you don't understand anything into it. In the next video, we are going to see how we can hack into this protocol.